Okay, AP Chemistry. We're moving on in the bonding notes. And so we're on page 2. I talked about pi bonds, or I hope I did. If not, I'll go back and make a video to backtrack. But we're picking up with the fact that we've talked about pi bonds and that there's always a sigma bond first. These pi bonds occur, remember, pi bonds are a double bond or a triple bond, and they occur if you have like an SP or an sp2. They don't occur with sp3s because there's not enough space. So in your notes, there's not enough space. There's not orbitals. If they obey the octet rule, then you have 2 going with one bond, 2 with another, 2 with another, 2 with another. So you're never going to have an extra set to form that double bond. So if you look, we're at, I'm sorry, this bullet point right here. And this bullet point that says this is the formation of an sp2 set of orbitals. It says 3 orbitals formed, 3 sites, 3 letters. So we have an example, and I'm going to show you the 3 bonding sites. So I have, if we look at each individual carbon, so it gives you the example of ethene, either earlier or later on. Yeah, it says then this molecule would contain a double bond like ethene. The molecule serves a set of P's to form the pi bond. So I'm going to show you what that means. So here's ethene. Hopefully you remember organic chemistry and names. Ane is a single bond, ene is a double bond, and ine would be a triple bond. So I automatically know eth is 2, and so it'd be 2 carbons with a double bond. And here we have it. And I should have drawn it not so up at the top, so I'll do it again, I guess. I'm learning as I go with online stuff. And so we have, if we look at either carbon, they all have the same. They have 3 orbitals and 3 bonding sites. So we have, they've already said that this would be an sp2 hybrid. So that would be 3 orbitals representing the 3 different orbitals. It's 3 letters, so it's sp, p, and then it's the 3 bonding sites. So this would be a bonding site here. Electrons are here, electrons are here, and electrons are here. For this carbon, same thing for this one, there's some here, then we have some here, and some here. So each carbon has 3 different bonding sites and different orbitals. So if you're looking at this, this is like it already drawn out. And I want y'all to realize those that it's the 3. So that's talking about like an SP and P. So that's how you get the sp2. So if you can draw the sites and just remember that it goes S, P, 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 and then you go to your Ds, you should be able to predict hybridization fairly easily. And then the thing that you also need to understand conceptually, which is drawn really well in your notes, is that the pi bond is wrapping around. Remember, we said the sigma bond is on the axis. So if we were to draw it with like electrons bonding, you have it specifically separates the 2 P's for this pi bond, and we know we only have one of them. But if you think about carbon's electron configuration, where all of its electrons are at, it would be a 1s2, 2s2, 2p4. So we have a 2p4 here, and we know that hydrogen is just a 1s1. So we have carbon, which has these different ones. We care about our outer electrons, so we care about these guys, and then hydrogen. So hydrogen is going to take its 1s, and then carbon would have its, probably its 2s, and same with this one. So you'd use up those, and then one of its p's is forming that sigma bond with the other carbon. So this is our line, but it reserves one of the p's. So this could be a 2p1, this could be a, that's not a 4, that's a 2. Oh my Lanta. In total 4 valence electrons. I'm glad I caught that. Nobody's perfect. So anyway, so this could be a 2s1, and this could be a 2p1. It doesn't matter, they're 3 and they're in the hybrid form. It's 3 orbitals in that hybrid form. And then you have the second 2p, which it reserves, and so this would be our sigma bond right here. This is our main one. And then that pi bond is off those p's, and they're gonna like wrap around essentially your notes have it something like this, to where the P bonds are sticking up and they go around that sigma bond, which is more or less what's happening. And so hopefully my drawing is not as good, but with my explanation, hopefully you can then look at your picture and read what it says and see what it's talking about. I'm not an artist and I don't claim to be, but hopefully conceptually my lack of art, but hopefully somewhat good explaining, can make that make a little bit more sense. Hybridization can be a little tricky, so that's building on what we know about pi bonds. And hopefully I'm wrapping up the whole page. I'm making sure overlapping unhybridized p orbitals that form p bonds. So you could have a second p bond, which if I did, it wouldn't be ethene anymore and there wouldn't be two hydrogens, but would go on the other side. So we have one here and then one here. That's essentially what's happening. They're reaching around that sigma bond. And then, yeah, I think that covers the whole page for page 3. For page 2. So if you have questions about this, please let me know, and I will try to look up other videos that maybe have more animation, better drawings, things like that, to try to help y'all. So this wraps up page 2 of the notes, and I'll move on to page 3.